This is proof of my slave select pin reading. This is what I've been getting. As you can see, I have the scope, the settings, and this is the output. This is my connection from there. I have just a simple wire, male to male, connected to my oscilloscope. Both of them are plugged in over here, my USBs. This is to the Zybo, this is to the digital wave, or the digital and analog discovery. That's my output to that, just to prove that it does actually read. I am going to connect the wave generator to the oscilloscope with that same wire so that there's no other connection problems. I know it doesn't look like this reading. That's because I have this waveform being generated at 50 hertz, so a 20 or 16 microsecond is not going to see anything. I'm just going, if I just do 500 milliseconds, that's not even going to be close to enough. Let's see, 20 milliseconds. There we go. That's the sine wave that is being generated here. Again, 50 hertz, amplitude 1, all that good stuff. Into the scope, exactly what we see, amplitude 1, 50 millisecond, or 50 hertz. So yeah, that is my problem with measuring the data rate. I'm going to sleeve select. And I'm not even getting, oh, that's because I have the sampling rate way too low. Let's just do 50 millihertz. There it is, my individual pulse. Now, just to prove that I do know what I would have had to do to measure the sampling rate, it would be 1 over the time from the beginning of this pulse to the beginning of the next one. However long that would have been. If that was 10 microseconds, it would have been 1 over 10 microseconds is the sample rate. And the active period, I believe that's what the other task that it calls for. The CS pulse, so it's active low, inactive high. Right, so the inactive, or the active low would be the time from the beginning of this pulse down, I guess, I don't know, however you want to call it, the beginning of this dropping to 0 to the end of it, or to it going back up to 3 point whatever that is, that would be the active low, because it is, when it is low, it's when the pin is getting the data. And then the inactive high would be the time from it coming back to this 3.2 or whatever it is, approximately 3.2, until it goes back down to 0. And the sample rate, like I said, would be 1 over that time from the beginning of an active low to the next beginning. And taking out what task 3 is doing, it's doing the same measurements, but while taking these two lines out, what those two lines would do would just make the sample rate significantly faster, because it would not be sleeping. Instead of, I'm just going to clear this to show, right now in the basic it prints out about every 1 second, and it's reading and printing out every 1 second. Take those out, there wouldn't be any printing, but it would be reading pretty much non-stop. You'd be getting thousands of samples per second, which is evident by my code for the tasks 4A, 4B, 4C with the other project, including the GPIOs, because I actually do take both of these lines out so that I get a proper sampling rate to be able to do tasks 4B and 4C so that they work properly, because the symmetry would not be able to be calculated with only 10 samples in a 10-second wave. You would get very bad readings, you'd get very inaccurate readings, and for task 4B, you'd get some random lighting ups of the light, because it could have easily, especially with a low symmetry, it could easily jump from 0 volts to 800 millivolts in a second. And that would go from no lights on to 1 light on in 1 read. So that is why I removed these two from my code in the second project, and that is what would happen removing them. It would just increase the sample rate. This is why I have no calculations, like I said in the manual, and this is my video just proving what is going on and that I cannot get it. Maybe I'm doing something wrong, but I'm following everything with the connections. I showed that the oscilloscope does read a signal properly. I showed in my project that this port does work, in fact, and that the project ran smoothly. So I'm at a loss for what is happening. And I've tried it with the header in here, and it doesn't do anything differently. This was just the easiest way to flip it from where it currently is into the waveform generator. Because the header gets annoying and does not stay as well during movement. So that is my proof of this.